So here we go. This is 13.7 solve basic trig equations. First up is solve 2 sine of beta, take away root 3 such that beta exists between 0 and 2 pi. So don't be intimidated by the fact that it's trig. Just focus on doing the easy things first. So I notice I've got this, and I notice it's also got a huge typo. It should say equals 0. Too bad I've already made copies of these notes. Sorry. So anyways, what we're going to do is we're going to take that negative root 3 and we're going to shift it over. And that's going to give us 2 sines of beta equal to a positive root 3. And the next easy move would be to divide by 2. Remember, we do easy. So we have that the sine of beta is root 3 over 2. Now, technically what this means is that beta is the arc sine of root 3 over 2. And you need to be thinking about what that's asking you to find. That's asking you to find the angle that has a sine ratio of root 3 over 2. Now, most of this page has been designed to be circular. It's all about the unit circle. So again, it's asking what angle has a sine ratio equal to root 3 over 2. Now, I really shoved the unit circle down my kids' throats. So on the unit circle, the sine of an angle is y. So I'm thinking about unit circle concepts here. And on the unit circle, that one didn't do such a hot job there, did it? Where is the y-coordinate root 3 over 2? It's going to be about right here and about right here. It's going to be at 1/2, negative 1/2, positive root 3 over 2, and then positive 1/2, positive root 3 over 2. Now, where did that happen on the unit circle? That happened at 60 degrees and 120 degrees. Now, the original context of the problem, though, was to return beta as a pi rad. So 120 degrees is going to be 2 pi over 3, and 60 degrees is pi over 3. And those are my two answers, all right? And it does have two answers. One of the betas is going to be pi over 3, so hence beta 1. The other beta is going to be 2 pi over 3. There's your first example. If you know the unit circle, this stuff isn't that bad. It's like really not that bad. But if you don't know the unit circle, it's a lot harder, and I just don't have the time this morning to teach the triangular approach. I really don't. I'm going to approach all of this as I can with the concept of the unit circle, because the unit circle is quick. All right, solve 9 tangent squares of x plus 2 equals 3 such that x is an angle that lies between 0 and 2 pi. So we're still dealing with radians, or 0 to 360. And the easy thing to do on this one is to subtract the 2 first. So we're just going to take that 2 over. 9 tangent squares of x is equal to 1, because 3 minus 2 is 1. And the next easy thing to do is divide out that 9. And we'll have that the tangent squared of x is 1/9. Now, I want to get in a position where I can do arctangent. So I'm going to have to counteract the squaring operation on both sides. This will give me that the tangent of x is plus or minus 1, because that's the square root of 1, over 3. And bummer, this is not a circular concept. So as much as I tried, I'm going to have to switch over technology and probably do some things in the calculator that you may or may not see. This means that the measure of angle x is the arctangent of plus or minus 1/3. Now this thing's going to have 4 answers. All right. I'm going to work in degrees and I'll convert to radians in a minute. So I'm on my TI-84 here. I'm in degree mode and I'm pressing arctangent of 1/3. So the arctangent of 1/3 is going to be 18.43 degrees. And now I'm going to do the arctangent of negative 1/3, which shouldn't surprise you too much, is negative 18.43 degrees. Worked out pretty good. Now, there's more answers than this. because this guy is both positive and negative. I don't know, I spelled negative Meg, like Meg from Family Guy. It's both positive and negative. And I got to think about the old acronym ASTC. All trig ratios positive, sine, cosecant positive, which means tangent's negative, but it's there. Tangent's positive, got a positive number. Cosine's positive, tangent's negative, but I got a negative. These angles exist in all four quadrants. Like I said, there's going to be four answers to this thing. So the two that they gave me were decent answers. I just have to do some work with them. But most importantly, they're reference angles. Now, one of my answers for this thing is going to be 18.43 degrees. I'm not going to accept the negative one because the problem originally said between 0 and 2 pi. So I'm going to think about the positive rotation of the same location. And that's the second one. If I do 360 minus 18.43 degrees, I'll have a 341.57. There's two answers. Now, like I said, there's four because I can still exist in these two quadrants right here. So reference angles, they're 18.43 degrees. This angle right here is all of the semicircle or straight angle with the exception of 18.43 degrees. So it's going to be a 180 minus. Which is going to be 161.57. And then we have the last and the final of the four answers. You're going to have a 18.43 degree reference angle in quadrant 3. And then you're going to do rotation there. It's going to be a 180 plus operation because you're covering a semicircle or a straight angle plus a little bit more. And that's the fourth one. So it's going to be 198.43 degrees. Now, the fun part is that all of these things have to be expressed as radians. And they're not going to be pretty. But what we're going to do, and I'm not only going to show you what I'm doing for the first one, I'm going to take 18.43 and I'm going to multiply it by pi over 180. Exactly like that in the TI-84. That's how I'm going to do it. You couldn't see me type right any of that, could you? I really need to pay attention to where I'm at on these things. I'm going to take the 18.43 and I'm going to multiply it by pi over 180 because that's how we convert an angle into degrees, or for an angle that's in degrees into radians. And it's going to get me about 0.322 rad. What do you say, 0.32 rad? It's not a pi rad, it's just a rad. And I'm just going to repeat the process for everything else. So 341.57 is about 5.96 rad. This is about 2.82 rad. We got the 198.43, and it's about 3.46 rad. Pretty lengthy little problem there, wasn't it? I did not expect it to take me that long, but it did. Such is math, kids, such is math. Of course, I know kids in high school complain about how long things take. You have no idea how long some things can actually take. If it was supposed to be quick and easy, it probably wasn't worth doing. And that applies to a lot of things in life. Quick and easy is often not worth it. Alright, solve sine squared of twice x minus 4 sine of 2x over the interval from 0 to 2 pi. This is one of the tougher ones because that 2x. And we've had this lesson. Normally, sine has a period of 2 pi. However, you have this guy right here, okay? That 2x. That's throwing things off. This function has a period of pi because this one is going to be 2 pi over 2. This function has a period of 2 pi over that 2, which is pi. So what that means is that the sine function on the interval from 0 to 2 pi, it's going to happen twice. It's going to do everything 2 times. So there's more answers here than is readily apparent, and it's a lot more work. But anyways, we're going to start off by factoring. All right? So there's that F word. I can pull a sine of 2x from each of those two pieces. If I pull a sine of 2x from sine cubed, I'm going to get sine squared of twice x. And if I pull it from a negative 4 sine of x, there's going to be a minus 4 left over. Still equal to 0. I'm going to keep factoring. You don't have to, but I'm going to keep factoring. Because I know that that sine of 2x will factor. Or sorry, that sine squared of 2x. Kind of think of this as x squared minus 4, which would factor as x plus 2 and x minus 2. So this factors as sine of 2x plus 2 times sine of twice x minus 2. It's all equal to 0. And now we're going to kick this thing with the zero product property. All right, this thing's got some work to it. I'm sorry, it is what it is. All right, so the sine of twice x is a 0, or the sine of twice x plus 2 is a 0, or the sine of twice x minus 2 is a 0. So 3 things according to the zero product property just happened there. Now, the first one is telling me that 2x is the arc sine of 0. And again, these are circular concepts. This one is a circular concept. Sine is 0 here and here because sine is y. So the answers here are that 2x equals 0 pi or pi. Now you divide out the 2 and you get x equals 0 pi or pi over 2. But wait, there's a whole lot more, and I'm going to come back to that in a minute, okay? The next one, you move your 2 over, and you get this. Now, nowhere on the unit circle is sine negative 2. The lowest that the y value actually gets to is negative 1. This is nothing. It is junk, and that happens a lot. And kids don't like to recognize that, but it is pure junk. The next one's also junk. This is saying that, well, I guess I'll go through it, but saying the sine of twice x is 2, which means that 2x is the arc sine of 2. Now, the biggest y value you'll ever see on a circle is 1. And a sine cannot exceed 1. It cannot be less than negative 1. And that's kind of a rule about the sine functions. They're opposite over hypotenuse. It's also junk. So here's 2 of the answers, and there are more answers. Since this thing has a period of pi, I have to basically just add pi. So if I plus pi to this thing, I have 2 answers there, 0 pi and pi. And if I plus pi to this one, I have pi over 2 and also 3 pi over 2. The reason I'm doing that is because over that interval from 0 to 2 pi, the trig function happens twice because it has a period of pi. So I have to add in the period to any answers that I have, and then I have the other answers. So challenging little problem, really was. You know, on your quiz that you guys have Thursday, now this doesn't apply if you're not in my class, obviously, but I gave you full credit for finding the easy answers, and I gave you extra credit for going around the circle because you kids are just in Algebra II. you know, a lot. It is. I often think we shove too much math down your throats. For most of you, some of you are ready for it, but a lot of you are not. It's a big problem in education. We don't do things as you're ready for them, or in a very appropriate manner, I feel. But what do I know? I've only been doing this job for 15 years. Solve 2 cosine squares of x minus 5 cosines of x plus 2 on the interval from 0 to twice pi. Another factoring problem. And what I'll do for y'all is I'll think of this as 2x squared minus 5x plus 2. And I'm using substitution. I'm saying that x is the cosine of x. I'm just using substitution. Now, 2x squared minus 5x plus 2 would factor as 2x and an x to get you your 2x squared. And we would need a negative 2 and a negative 1 because the outside is going to make negative 4x and the inside is going to make negative x. And negative 4x plus negative x is negative 5x. Anywho, equal to 0. Now, some teachers will go ahead and figure out what x is here and then substitute in. I got no issues with that. If you want to do it that way right now, that's fine. 2x minus 1 is 0, so x is going to be 1/2. X minus 2 is 0, so x is 2. Now remember that x was cosine of x, so the cosine of x is 1/2, or the cosine of x is a 2. Now, again, unit circle. Your unit circle. The biggest x value, which is cosine, is 1. A lot of kids will not remember that the cosine ratio cannot exceed 1. So I have found that the unit circle is a better approach to getting kids to realize extraneous stuff or stuff that doesn't make any sense. Garbage. So I'm going to focus on this one now because I know that I can have x values on the unit circle between negative 1 and 1. And I know that there are x coordinates on the unit circle of 1/2. So I'm thinking about my circle. And I know that there is a 1/2 here and a 1/2 here. This is going to be 1/2 root 3 over 2. And this is going to be 1/2 negative root 3 over 2. Now, where did those answers happen? Those answers happened at 60 degrees, or pi over 3, and down here at 4 pi over 3, or 240 degrees. So there's your two answers, pi over 3 and 4 pi over 3. I feel like they're your two answers. And I'm the teacher, so let's go with that. All right, I think there's 3 left, and I've got just a little bit of time. First period is going to start pretty soon, so I got to be done pretty soon. We do have a word problem in here. It ain't too bad. This one's kind of interesting. You're going to have to use some concepts of trig identities to do this problem. It says solve the tangent of theta times the sine of theta, take away 4 tangents of theta equals negative 3 tangents of theta. A whole lot of stuff going on there, huh? Over the interval from 0 to twice pi. All right, so tangent, I believe, is sine over cosine. And let's do the easy thing first. Let's get this thing set equal to 0. Let's add that to both sides. And I am going to write tangent as sine over cosine. So sine of theta over cosine of theta times the sine of theta. And if I add 3 to that one minus the tangent of theta is 0. Now, sine times sine is sine squared. So sine squared of theta over cosine of theta minus tangent of theta, which is also sine of theta, is also sitting over cosine of theta, is 0. There's a couple of things I could do here. I could combine those two pieces, or, and hear me out here, I could clear the fractions. What I'm going to do is I'm going to multiply every stinking thing in this thing by the cosine of theta. And that's going to make the fractions disappear completely. And I am left with a line that says sine squared of theta minus sine of theta is 0. Now, factoring, favorite F word. Both pieces contain a sine of theta. If you pull a sine of theta from sine squared, you get sine of theta left. If you pull a sine of theta from a negative sine of theta, you got your negative 1. And now you get to use the old zero product property. The sine of theta would be 0, or the sine of theta, think about adding 1, is 1. Now, I've done a couple of these where I wrote out using arc sine, and I'm not saying you're not. This is saying where is the sine ratio 0? What angle has a sine ratio of 0? So if you think about your unit circles, that's going to be there and there, right? Because that's the y values. So it's going to happen in 0, pi, and pi. Where is sine 1? That's up there. That's where the y value is 1. That's 3 pi over 2. Easy, man, easy. If you know the unit circle trig is so easy. It is so darn easy. I just wish you kids would memorize that thing. And it just makes things click. Oh, it makes everything click. Now, if you're another teacher who teaches trig and you are not making your kids memorize the unit circle, you are not doing your job. Like, before you even talk about SOHCAHTOA, make them learn that unit circle. Before you ever even talk about 30, 60, 90 theorem in geometry, you make them kids memorize that unit circle. And even if you're just teaching, geometry, and you're like, but that's not a big deal. It's not in my standards. I'm not going to get tested over that. It'll make the stuff click, especially if you put a lot of little stuff off the side like I do. The water depth D for the Bay of Fundy, which I have no idea where that is, can be modeled by depth equals 35 minus 28 cosines of pi over 6.2 times t, where D is measured in feet and t is the time in hours after midnight. At what time is the water depth 7 foot? So first things first is where you're going to put the 7. You're going to put that 7, I don't know why I'm touching my laptop there, in for D. So we're going to write 7 equals 35 minus 28 cosines of pi over 6.2 times t. Now I do want to point out that this is a radian. Okay? That is a radian. I'm going to do our easy stuff just the way I teach it. We're going to subtract 35. We're going to get negative 28 equals negative 28 cosines of pi over 6.2. I don't guess it matters that's a radian, because looking at this thing the way it's going to work out. That's a t, not a plus symbol. And we're going to divide out the negative 28, and we're going to get something that I like. We're going to get that 1 is the cosine of pi over 6.2 times t. Cosine of pi over 6.2 is something that I'm just going to go to my T84 and I'm going to push buttons. Okay? What is that? So I'm putting my TI-84 in radian mode, because that is a radian. And the cosine of pi over 6.2 is about 0.874, roughly 0.874. So 1 is about 0.874 times a t. And now we just do division. So 1 divided by 0.874 is roughly 1.144. Sorry, 1.14 hours. And this was after midnight. Now, there's other answers to this equation. There's actually several. And I just don't want to run my Algebra II kids through this one right now. I'm okay with that one. But there are more answers, because tide rises and lowers. So there will be a second one. And it should be, so if this would be, 1.14. This would be like 1:08 a.m. or something here. What's 0.14 times 60? Yeah. So it's like 8 minutes. It's an hour and 8 minutes. So this is like 1:08 a.m. because it's hours after midnight. Presumably the next one, because I have not seen anything in this thing change, The next one is probably 12 hours later, so around 1 p.m. But I don't, if I had this up, we'd do this, but I don't. So we're going to stop that one. I probably won't even do that one in class because this is taking a lot longer than I anticipated to do. And the last one. Solve 1 plus cosine of x equals sine of x over the interval from 0 to twice pi. Now, when I look at this one, I was thinking about the Pythagorean identity, the most important of all the Pythagorean identities in the trig world, that the sine squared of theta plus the cosine squared of theta is 1. And what you're going to want to do is you're going to want to make that thing on the right, sine, become sine squared. And the way you do that is by squaring. And if I square the right, I have to square, boy, I messed up on that one, the left. That's what I have to do. So the right side is going to be easy. You take sine, you multiply it by sine, you get sine squared of x. You know, on the left-hand side, you're going to have to write 1 plus cosine of x twice, and I guess you're going to have to FOIL, right? Or double distributive property, whatever you want to call it. It's not necessarily hard. You'll get a 1, that's there, plus a cosine of x, plus another cosine of x, and a cosine times a cosine is a cosine squared of x, and it's still equal to sine squared of x. On the left-hand side, if you put everything together with the highest exponents first, you'll have cosine squared of x plus 2 cosines of x, and then plus 1. And it's still equal to sine squared of x. Now, the issue we have here is we have a mixture of sines and cosines. And there are ways of doing this creatively in your head, but I could not explain it to you. It's about knowing the unit circle and knowing where things are true and analyzing results. So the algebra is the way to show it. It's based off this. If I simply move cosine squared over, I have something that I can substitute in place of sine squared. Because sine squared becomes 1 minus cosine squared. So now what I've done is I've created equations where everything is more or less likes. They're all cosines. That's kind of a goal, get everything to be in cosines. And we're getting to a position here where we can set this thing equal to 0, and we can use the zero product property. I'll take away my 1, they will cancel. I will add a cosine squared over there. Now cosine squared plus cosine squared is going to be 2 cosine squareds of x. Okay, this marker just doesn't want to work for me. And then I have the plus 2 cosines of x that's already there. And it's all equal to 0. And again, your favorite F word is factoring, right? That is your favorite word. You love that word. It loves you. So what can we pull? We can pull a 2 cosine from both pieces. If you pull a 2 cosine of x from 2 cosine squareds of x, you'll have a cosine of x left. If you pull a 2 cosine of x from a 2 cosine of x, you have the 1 kind of as a placeholder idea. And now you can use your zero product property. So you have 2 situations here. Either 2 cosine of x is 0 or cosine of x plus 1 is 0. So 2 cosines of x is 0 or cosine of x plus 1 is 0. So this one, we divide out the 2, we get that the cosine of x is 0. Now on your unit circle, because that's what this is about, x is 0, not there, there and there. That's where x is 0, right? That's 0, 1, and that's 0, negative 1. So the answers here are going to be pi over 2 and 3 pi over 2. Subtract the 1, we'll have that the cosine of x is negative 1, which is over here, negative 1, 0. And that's at pi. And you get the other answer, pi. And there you go. There's your 3 answers. And there are the notes for 3-7.